Welcome to PreMath. In this video, we have got this purple shaded region fully confined in a semicircle with the center O, as you can see in this diagram, such that this angle of inclination CAB is 15 degrees. And moreover, this diameter of the semicircle is 16 units. And now our task is to calculate the area of this purple shaded region. Please don't forget to give a thumbs up and subscribe. Please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. We know the diameter of this semicircle is 16. So therefore, its radius R is going to be half of that one. So the radius is going to be 8 units. So therefore, this AO is going to be 8 units. And likewise, this OB radius is 8 as well. And here's our next step. Let's go ahead and connect this center O with this point C, as you can see in this next diagram. And as a result, we got this triangle AOC. And we can see that this triangle AOC is an isosceles triangle, since this is our radius, and likewise OC is our radius as well. So therefore, this OC length is going to be 8 units as well. And now, since this is an isosceles triangle, if this angle is 15 degrees, then this angle has got to be 15 degrees as well. And now let's recall triangle sum theorem. According to this theorem, the sum of the three interior angles in a triangle is always 180 degrees. Therefore, in this triangle AOC, this angle is 15 degrees, this angle is 15 degrees. So therefore, this angle AOC is going to be 150 degrees. And here's our next step. Let's recall the straight angle property. According to this property, this straight angle is going to be 180 degrees. And we know that this angle is 150 degrees. So therefore, this angle has got to be 30 degrees. And now let's make an observation. We can see that the area of this purple shaded region is going to be equal to the area of this whole sector AOC minus the area of this triangle AOC, as you can see in this equation. And now our task is to calculate the area of this sector AOC, and likewise the area of the triangle AOC as well. And in this next step, I have dropped this perpendicular CD, as you can see in this diagram. And as a result, we got this right triangle ODC. And this right triangle, this angle is 30 degrees, this angle is 90 degrees. So therefore, this angle has got to be 60 degrees. So therefore, we can see that this our triangle ODC is a special 30, 60, 90 triangle. And here I have copied down this triangle ODC. And now let's make an observation. We can see that 30 degrees is our smallest angle. So the side opposite to that one is going to be our smallest leg. And this is our 90 degrees largest angle. So the side opposite to that one is going to be our longest leg. So in such kind of 30, 60, 90 triangle, the longest leg is twice the smallest leg. In other words, if the smallest leg is 1 unit, then the longest leg is going to be 2 units. And now we can see our longest leg is 8 units. That means this OC length is 8. So our smallest leg is going to be 4 units. So therefore, our this CD length turns out to be 4 units. And here's our next step. Let's go ahead and calculate the area of this sector AOC. And now let's recall the sector area formula. Area equals to theta divided by 360 degrees times pi r square. And in our case, our angle theta is 150 degrees and our radius r is 8. So therefore our sector AOC area is going to be 150 degrees divided by 360 degrees times pi, and our radius 8 whole square. And now if we reduce these fraction, that is going to give us 5 divided by 12, and likewise 8 square is 64. So therefore we can write 5 divided by 12 times 64 pi. And now let's multiply and simplify. That is going to give us 80 pi divided by 3 square units. So therefore sector AOC area turns out to be 80 pi divided by 3. And now we are going to calculate the area of this triangle AOC. And now let's recall the area of a triangle formula. Area equals to a half times base times height. And in our case, our base of this triangle is 8 units, whereas the height CD is 4 units. So therefore the area of this triangle AOC is going to be a half times our base is 8 times our height is 4. And if we simplify everything, that is going to give us 16 square units. So therefore the area of this triangle AOC turns out to be 16. And here's our final step. Let's go ahead and calculate the area of this purple shaded region. And we already figured out the area of this sector AOC, which is 80 pi divided by 3. And likewise the area of this triangle AOC, which is 16. So let's go ahead and fill in the blanks in this equation. So our sector AOC area is 80 pi divided by 3 minus our triangle AOC area is 16. So thus our purple shaded region area turns out to be 80 pi divided by 3 minus 16 square units, as you can see over here, and that is approximately equal to 67.8 square units. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.